Greetings, mathletes. Let's take a gander at a few questions from section 5.1. Number 11. Compare and contrast the graphs of f of x equals the absolute value of x and the graph of f of x equals x. How are they alike and how do they differ? So let's look at the first one here. F of x is equal to x, absolute value of x. We've already done this one, and I'm going to do this one in green. After you graph all of these, notice it goes in the positive direction like so, and it goes forever there. However, it bounces and stays in the positive realm always, right? So if we consider what its domain is, the domain includes all of these numbers here, right? It's in the negatives, zeros, positive. So the domain is all values of x. So the domain is going to be all real numbers. There we go. Now what's the range? The range are what values of y come out. So notice 0 is here, 1, 2, 3, 4, 5. It goes upward, but notice the arrows only point up and left and right, but never go in the downward direction. So there's a restriction here. In other words, we never get negative numbers. So my domain is all real numbers, but my range is y is greater than or equal to 0, because the range goes up like that. Okay, so what about the function of x, just f of x equals x? What does that do? Well, it's pretty much the exact same for half the graph. So here goes up in this direction. However, it doesn't bounce. It goes down in this direction. So to clean that one up, looks like so. And what is true? Well, the domain is the same. The domain is all real numbers. Again, let's see why that's the case. So if we see here, this is the value of x, value of x in the negatives, 0, and the value of x in the positives. Again, domain is kind of like casting a shadow. If you put a flashlight right here and you cast a shadow onto the x-axis, where does the shadow lie? And the shadow is all along the x-axis, goes forever in both directions. How about the y-axis? Well, I cast a shadow this way. It goes all the way up forever. Oh, and it goes all the way down forever as well. So here's a major difference, is that the range is also all real numbers. So how are they the same? Well, for quadrant 1, they're exactly the same. Look, quadrant 1, they're exactly the same. However, this function goes into quadrant 2 because it bounces, and this one goes to quadrant 3 and just extends. So this one is a straight line, and this is sort of like two lines, or two rays actually, because they start and never end. So two rays connected but going in different directions as opposed to opposite directions here. All right, so that's number 11. Now, continuing on, here's number 16. Tell whether each point is on the graph of f of x equals absolute value of x. If it is, give the coordinates of another point with the same y value. Well, how do we know if the point is? Well, if I substitute this value into there, I should get this value, right? So f of 11 equals the absolute value of 11, and that equals 11. So I input this and I output this. So look, there's output. I put in the 11 and out comes 11. Okay, so now the next part says give the coordinates. So first off, let's answer that question. The answer is yes. Okay, now the second part, if it is, give the coordinates of another point with the same y value. So what is another number that I can insert into this function here and here, and I get the same number? So a different number in, but the same number out. Well, clearly the absolute value just takes the opposite. It just not opposite really, but it takes the opposite of negatives. So notice here, if I substitute a negative 11 in, what comes out? A positive 11. So there we go. Input 11, output 11. Input negative 11, output positive 11. So there we go. So what's the other value? Give the coordinate of the other value. And the coordinate of the other value is going to be negative 11 yields me positive 11. So the answer is yes, and here's the other point. And the same thing would hold true for number 17. Notice in number 17, if you insert this one right here, a negative 2.3, into here and here, and you take the absolute value, you should get positive version. So that's not what you get. You don't get the negative out. You get a positive out. So this one would be a no. All right, graph each function. What's the domain of each function? So looking at number 22, graphing the function. The only way that we've shown you how to graph this is to make a table of values. So I'm going to input an x and output a y. Now the easiest thing for me to do is to choose values that can easily divide by 4 there. So I would choose multiples of 4 essentially. So if I chose a negative 4, a 0, and a positive 4, and even an 8, let's see what happens here. So when I substitute in g of negative 4, I get this. Negative 1/4 times the absolute value of negative 4. And what do I get? I get negative 1/4 times positive 4, and I end up getting, I'm running out of space here, so let me move that over, equals negative 1/4 times 4, which gives me a negative 1. Plugging in a 0, I end up getting a 0, and plugging a 4, I also get a negative 1, and plugging in an 8, I actually get a negative 2. And you might ask yourself, well, how am I getting negatives? I thought absolute value gives me positives. You're right, the absolute value of this part right here gives you a positive, but now we're multiplying that always by a negative. So this function will always give me negatives. So now how do I graph that? Well, notice that my domain is going to be all real numbers, so everything in the x will work, all these values of x, but my range is going to be negatives. Look, or including the 0. So my negative's there. So if I count it off here as 2, negative 4, negative 8, like this, and here's a 4, and here's an 8, and the other scale here, I'm counting by ones, negative 1, negative 2, negative 3. This one's negative 2, negative 4, or excuse me, 2, 4, 6, 8, etc. So how does this work? If I plug in a negative 4, I get out a negative 1. 0 gives me a 0. A positive 4 gives me a negative 1. An 8 gives me a negative 2. And I could actually predict this one here, and predict this one here, predict this one here, like this. And there we go. So here's my graph. Like so. So what's my domain? My domain are all real numbers. Any x is allowed to go in. But what kinds of numbers come out? Well, y is less than or equal to 0, because I'm getting 0 and all the negative numbers. There. So that's how we graph it right now. Right now we're just using a table of values. But notice the negative 1/4 here. Down 1 and right 2, 4. Down 1, right 2, 4. Down 1, right 2, 4. Down 1, left 4. Down 1, left 4. Notice that my scale is different here, so that's why I'm counting ones here, but 2, 4 that way. So 1/4 actually is going to help me graph it faster later. All right, the last question here. For the graph shown, find the rate of change over the interval. So we're just going to look at the interval from 3 all the way to 6. From 3 to 6. So we're looking at this region right here, from 3 to 6. So how do things change from here? And notice, essentially, that's all we're doing, is we're finding the slope. We're finding the slope, because that's rate of change, from this to here. That's it. From 3 to 4 there. All right, so all we're going to do is count it up. Go up 1, 2, 3, 4. So up 4, and then right 1, 2, 3. And there we go. There's my rate of change. My rate of change is 4/3 for this particular region. Notice at a different region, 7 to 10, it's going to be a different because this one goes down now. So we're just pointing out that the rate of change changes in this for this type of function. There you go. Hope that helps.